Okay, good evening all. Thanks for joining. I hope my voice is clear. Okay, so
Yes, ma'am, it's
let's wait
clear.
for, yeah, thank you, sir. So myself, Professor Niveta Suma, and we have Professor Rajesh who will be handling your queries. So let's wait for another 1 minute for some more students to join. Then we'll start the session directly. Thanks for joining. Okay, thanks for waiting. Let's start the session. So, to be very precise and to make use of the next 1.5 hours effectively, let's not use the chat box in the middle of the session. So, we'll give around like last 20 to 30 minutes to answer all your queries. So, or everyone can have a single chat string, post all your questions over there, and myself and Professor Rajesh will answer within the end of this webinar. Okay, so all your questions related to the webinar's content and also any special questions related to assignments. I think probably during our last session, Professor Jayalakshmi has already addressed like how to use the virtual lab and everything for the assignments. And still, if you have any questions related to the assignment submission, we are there to answer you during the end of the session. So in order to not to get disturbed in the middle of the session, let's not use the chat box in the middle of the session. I hope it's fine. So let's start the session. I'll share the screen. So basically, before going very deep into the topic of the webinar, linear regression, multiple linear regression, and polynomial regression. Okay, first we need to understand what is a like end-to-end ML pipeline. So it's not like I'm going to give you an overview of like what is an end-to-end pipeline, because the upcoming webinar 2, we have a very detailed session on end-to-end ML pipeline using all the whatever the process that you do after you get the data, and everything is there, is well explained with the code. So before that, to give you an overview, I have just this image. So any pipeline, ML pipeline or a DL pipeline, any AI pipeline will start with the data. So the data quality is very important, because however costlier or expensive model that you have, intelligent model you have, works perfectly based on the data. 80% it relies on the data quality. So that's why the first module that we have is the data source. This data source especially can be a static data in the form of CSVs, Excel, XLS, or text TXT format, or image, anything. And it can be a dynamic data also. Whenever you go into a real-time production environment or real-time environment, there you get dynamic data where all the real-time data will be fed into your ML pipeline through some big data softwares and stacks. And then once you get the data, right, but probably during our our learning period, we'll be using an experimentation period, we'll be using the static data, right? So it's for simplicity of understanding. So then once you load the data and once you got the data, right? So the next step is like, you need to understand the data, because you, as a analyst or as a data analyst or as an AI engineer, you are very new to that data, right? So first we need to do an exploratory data analysis. It's basically, right, some kind of, you're trying applying statistics or like applying some graphical graphs and like some kind of plots to better understand the data. What is the data? What is about the data? What is the statistics of the data? And all these things you're understanding, so that you know whether there are any noises, whether there are any outliers, whether there's any missing values. All these kind of things you'll be handling in EDA. And the next thing, once you are done with the learning the data and doing the EDA, I mean, basically the cleaning the data and all, the next basic step is like, you need to segregate the data into features and target, which means you need to know what are the features. Generally, a regression problem or a classification problem, right? You'll have a set of input features and an output variable or a target variable. You first need to understand what is the input feature or input features, okay? Features, or what is the target variable. I mean, input features usually it's represented in terms of X, and target variable is represented in terms of Y. That's a generic convention, okay? And then once you segregate the data set into features and target, then what you do is like, you split the data into training data set and testing data set. Training data set is basically to train the model, to make the model to learn the patterns, okay? Then you have the testing data. This test data is actually hidden from the model during the training period. And this, once you train the model with the training data, you'll have a trained model, right? Now you're going to check the performance of the model using the test data. Like you're just letting the model guess. Okay, you haven't seen this data, right? So what is your prediction on this unseen data? So this will give you a clear-cut idea of like how well the model is trained. Okay, so then we do a kind of like training data pre-processing. Like this is already done in EDAs and all, right? So then once you split the data into train and test set, the next basic very important phase is the building the model. So building the model is an important phase. This is where whatever we are learning in terms of a lot of regression models, the classification models, SVMs, clustering, like even unsupervised learning, all these models fall into, like, you're going to fix this model into this phase, building the model. So once you build the model, you're going to do a training, and then you're going to do the testing using the trained model. And then that is where all the training and testing, or the testing phase will get involved in this model evaluation. You're just evaluating the performance of the trained model using the test data set. And finally, once you have a satisfactory performance, you're going to deploy the trained model into the production environment. This production environment, basically we call it as like model deployment. So this model deployment can be in a server or a local architecture, local server architecture, or it can be on a cloud. So in cloud, usually when you know about like, I mean, I'm just giving you some softwares that we'll be using in cloud for deployment. So usually you would have heard about SageMaker. There is something called as AWS Monitor. All these things will be used for your model deployment in cloud. So each of the cloud services have their own services, okay, to deploy the model. So once the model is deployed, we keep continuously monitoring the performance. There'll be some upper and lower bound. So whenever the error metric value goes beyond or goes below the the bounds, then retraining is triggered. So the retraining is done with the new data, not with the old data. Okay. So this is what it happens in uh, real time scenario. So I mean, it to some of you it might be familiar, and to some of you it might be like more complicated. So as of now, don't worry. So we are just going to like talk about only the loading the data, from loading the data to building the model and model evaluation. Okay. So like don't worry about too much of there are like a lot of um, techniques involved in each phases, but still we'll just go in detail about it on the upcoming webinar. Now we'll just restrict only to the model building and model evaluation. Okay. So basically in this webinar, what we are going to see or what you're going to focus is the simple linear regression, multiple linear regression, and linear polynomial. Now you can just ask like why we have like 3 models, right? So usually each one of it have a different purpose. Okay, in simple linear regression, it is the equation is similar to y is equal to mx plus c. So you have like beta 0, which is the which is the intercept, and then we have the slope, and where x plus e, x is the feature, and beta 1 is the coefficient or the slope, and then we have the error term. So this equation is similar to y is equal to mx plus c, right? We are gonna we already know y is the target variable or the output variable, and x is the input feature. So from this equation, we know that we just have only one sorry, give me a minute. Yeah, we just have only one input and one output. To have this output, you're calculating the intercept, you're calculating the slope, and then you're calculating the some error term, or like you're basically considering this, and then you're taking the input feature and you're trying to output what is a y predicted value. Similarly, when I have more than one input feature, right, what can I do? Can I use a simple linear model? Yes, of course, you can use a simple linear model, but with some modification. So that is where the multiple linear regression model comes in. So here you can see you can have n number of features, and similarly you'll have the coefficients for each feature. And similarly, you can see that both are like linear models. Okay. So whenever you come to polynomial regression, right, what you do is like you try to increase the power of the input feature to a degree, okay, to a polynomial degree. So this is a basic difference. This one basically polynomial is trying to handle the nonlinear relationship between the data. So with this, I mean, all these for mathematical foundation you would have gone through in your weekend classes, but still this is just to brush up the basics. Okay. So we'll go to the code part right now. And then, okay. So before we dig in deeper with the coding, so what we can do is like, we'll first go through how does the data look like because we are using 3 different data set for all the 3 models. Okay. So what we can do is like, we'll just see, okay, here for simple linear regression, we have something called as salary year.csv, right? Okay. So here you can see this is the input data for the linear regression model. You have years of experience and salary. So here you can see this is the independent variable, which is the input feature, and this is the target variable, which is the output feature. So this data set says that if you have 1 year of experience, then your salary will be like this, 32K. When you have 1.1, then it is 45K. Similarly, like some random data. So, so we have about like 30 observations. Okay, so we have totally 30 observations. So here you can see that you can clearly see from the data that whenever the years of experience increases, the salary also increases, right? the salary also increases. So basically, there is a linear relationship between years of experience and salary. So here, okay, now we know about the data, right? So now let's dig in deeper with the how to uh, go through the coding flow. So in coding flow, what we are going to do is like first important thing is like you have to import all the necessary libraries that you have, like whatever libraries you want. Basically, you're going to deal with numerical data. Then you want NumPy, right? You want NumPy, and you're going to import NumPy to do all the manipulation, array manipulation, and mathematical like whatever like calculation that you want to do. And then you have something called as matplotlib, and you're going to import this for graphical representation for plots. Okay. So you can also like why we are using matplotlib. Like you also have something called a Seaborn, so that will give you a still like all these additional packages we'll see in the upcoming webinar. So this is basically since it's your webinar one, so it's basically like we are just touching up the basic packages. Okay. So then we have something called as pandas. Pandas is usually used to process the CSV or your input files, and basically pandas is used to read the data and process the input files. Okay, so matplot inline will always try to display your plots within the PYNB file. Okay, it's not like a separate window. Whenever you comment out this, then it will be like a separate window. So first step is like I've declared all the packages. So this is the basic thing. And then you have to import like, okay, I have all the packages. Now I want to do what I want to do is like, first thing is like, I want to load the data, right? So this is what I'm doing here. I'm trying to load the data and saving it in a variable called data set. So for that, I'm using pandas. I'm importing pandas as PD. So I'm just using pd.read.csv. This is a CSV file, okay? Whatever we have seen, the years of experience and the salary. So whenever you give data set dot head of 2, like let me give data set of 5. So the first 5 rows of the data set will get displayed, okay? And then we have something called as, we are going to declare what is the X variable, what is a Y variable, which means what is my independent feature, what is my target variable or the target feature. So for that, what I'll do is like, I have some function called as ilog. In ilog, what I can do is like, what I'm going to do is like, X is something, we know what is X, right? So X is this and Y is this. So for X, what I'm going to do is like, I'm going to select all the rows except, I mean, all the columns or the rows except the last column, right? So here that is what we are doing. So we are selecting all columns excluding the last column. So similarly for Y, I'm selecting only the last column. Okay. And then once I have the X and Y stored, the data set stored in X and Y for independent feature and the dependent feature. Now I can visualize the data, right? So I'm trying to visualize the X and Y. And then here we have the, like, we can just give what is the title of the graph, what is X label, Y label, all these things. So the data is getting plotted for 1 year of experience. What is the salary for 1.1? What is the salary? All these data is getting, this is just for our visualization. Okay. So next, you know, what is the step, right? So now what we can do is like, we are we have done this. So we are omitting this as of now. We have done this. We have segregated the data set into features and target. That is what we are doing in X and Y. And then what we need to do is like split the data into train and test. Okay. So here we are using, we already have a package called train test split from sklearn. So we can use this. And what we are going to do is like all the input variable, sorry, dependent variable, which is the X, sorry, independent variable, which is the X, and the dependent variable, which is the Y. We're going to split everything into train and test. So we'll have 4 sets. One is the X train, X test, Y train, Y test. And we are going to do the train test split for based on X and Y as input, and the test size is 1/3. So I have 30 observations, right, in my data set. From that, I'm going to take 1/3 as a test size. So which is 10 observation and 20 observation as a training data. So my train data will have 20 observation and my test data will have 10 observation. Okay, you can see that why for only this much small observation you need a model. This is just for your understanding, but whenever you go for a real-time scenario, usually assume that you have a electricity consumption data. You'll record the electricity consumption data every minute, right? So assume that for a day, how many samples that you'll get. Okay. So this is just basically for your understanding, we are limiting the sample size. So here we have something called as a random state equal to 0 because this split is done randomly. Okay. So for example, if I'm giving 1 or something, whatever probability that I'm giving, the train and test split will happen in that way. So here I'm just initializing to 0. So if you want, you can just change this also so that the train and test observation will get shuffled. So now you have done this loading data, segregation of data set into features and target. Then we have something, we have done this also. We have a train test and the test set. Next thing is like we have to build the model, right? So here what we are building is like we don't need to write a big code for linear regression. We already have a linear regression model in sklearn. We can import it. And this linear regression model, we are just creating the model in this variable. And this model, we are just fitting to the training data. So training data, we have to write the independent variable and the dependent variable. So we are trying to fit the model to the trained data. That means we are training the model. Okay. So for that training that is done, what is the, like usually when you train the model, how will you assess the model performance is through some error metrics, right? It can be mean square error, mean absolute error, root mean square error. Here we are using R square value. Okay. So, so for R square, we are just calculating the model score, and then we are printing the what is the R square value. So here the R square value is like 0.89. So you can clearly note this, okay, because in multiple linear regression, you can see an increase in the R square value because there we are using more features. Okay. And then the main thing that we talked about in the, give me a minute. The main thing that we talked about in the presentation slide is like we are going to calculate the slope coefficient and the intercept, right? See, basically we'll have this. Okay, to calculate the salary, that is y, I need the intercept and the slope, that is a coefficient, into x, right? That is the formula we have seen here. We need to have an intercept, we need to have a slope, and the what is the x to calculate what is y. So that's why we are calculating the slope coefficient and the intercept. So then now we have everything, right? Now we can do a model prediction for the test and the training set. So here you can see like, okay, I'm doing an X prediction based on the X training and then Y prediction based on the X testing. So here you can see what is the X train, what are my X train samples and what are the X test samples. And then you'll have a X predict, you'll have a Y predict. This is just for my analysis, okay? And then once I have everything, I need to see how well the model is fitting with the regression line, right? So that is why here I have the X train and Y train, and then I'm plotting the X train and X predict, okay? So here you can see, okay, salary, this is the regression line. It is fitting perfectly with most of the data, but still we have some kind of like, but it's perfectly fitting. That's fine. So similarly, this is for the training data set. And this is for the testing data set. Okay. So now you have made the prediction, you have the model ready. Now you can also like predict, okay. For example, if I'm giving, okay, what for 7 years of experience, what could be the salary? Okay. So according to the data that we have, for 7 years of experience, the actual value is 76K. Here also we are getting mostly nearby, right? The prediction is like just 596 difference. So then we have like, we can also calculate, I told you, right? Based on the R square, we fitted the model, but here we can also assess the performance of the model based on the mean square error. And also we can also have a variance score also. All these things is just reflecting what is the performance of the model. Okay. Similarly, all these optimization or like performance improvement is done basically in a regression model. It is done using gradient descent. For gradient descent, for this particular data set, for the linear regression, how can you visualize how does a linear gradient descent happens? Is a code we have given here. You can just go through and it will be helpful for your understanding also, like, because once you would have visited all these mathematical foundation in your classes. So here we can see that we all know that with the iteration, right, with the, like, once the iteration with the increased number of iteration, we know like we can get a better fit line. So that is what is happening here. And then we have a cost function also. You can see that the cost is decreasing based on the number of iteration. Okay. So this is basically the concept of linear regression. So if you have understood the basic flow and the concept behind this, then multiple linear regression and polynomial regression is an easy walk for you. So let's move on to the multiple linear regression. So before that, we'll go through the data set also for that. For multiple linear regression, the main difference is like here we'll have more number of features, more number of X variables. Okay. We have already seen this in this equation, right? We'll have more number of features. That is the only difference. So here from this, we can see that A, B, C, D column are the input features and the profit is the output feature, which means based on the spend, R&D spend, administration spend, and marketing spend, and the location, what is the profit for the company we are estimating. Okay. So now what is a major difference that you're seeing here is that all the columns are numeric, but we have only one column which is categorical. Categorical is like a group. Okay. So here when you see, we can do a one-hot encoding to change this categorical, or like, because it will be difficult for the model to process the categorical features. So that is why what we are doing is like we are doing a one-hot encoding. Assume that I'll have something called as, okay, how we are going to perform categorical encoding is like, assume that I have California, Florida, and New York. Okay. So wherever in the sample I have New York, I place the value of 1 over there, and remaining I fill it with zeros. Similarly, you can fill here California 1, 0, and 0, right? And next, Florida 1, rest is 0. So similarly, the model will fill all these things. We have, you don't need to worry about this. You have a header file for, package for this that will do it for you. So now you can just think of, okay, how can I still reduce the dimensionality or the number of columns, right? How you can still reduce the number of columns is like, okay, assume that I have only Florida and New York, right? When I place 0, 1, I know that it is New York. When I place 0, 0, I know that it is neither Florida or not New York also. Then it is California, right? So then I have 1 and 0. Here it is Florida. So when I convert, okay, from this one, I'm converting to 3 column. Okay, one hot encoding. But still I can reduce the dimensionality by removing the dummy variable trap, or like you can assume that one column can be a dummy variable, because without this also I can easily represent what is there in the categorical value. Okay. So this is the main change over here. Let me walk you through the code. Similar, this is very similar. We import the libraries, we import the data set, and we see what is the, like, we display what is a data set over here. And then we do the, like, okay, here what you do is like, except the last column, you push everything to X, and the fourth column, you're pushing it to Y, because you know that independent and dependent variable, right? Now, when you type Y, when you run this, you'll get all this profit, all these numbers. Okay, now is something like you have to process this, whatever I taught you right now, right? This one hot encoding, we have to do it. So for that, we have something called as a column transformer and one hot encoder. So this will basically do the one hot encoding for these, because here is 3, because we have 3 categories. And once you apply this column transformer and the one hot encoder, right, you'll get, your data set will get transformed like this. Okay, here you can see that you'll have a R&D spend, administrative spend, and marketing spend. That is these 3 columns. Okay. And then the state is actually displayed like the 0, 0, 1. 0, 0, 1. And then 1, 0, 0, 0, 1, 0. Okay. So similarly, for all the columns, for all the samples, this will get generated. So now what I can do is like, I can avoid the dummy variable trap, which means I can remove one row, right? So similarly, whatever we have seen in the Excel work, right? It's done here. It's 0, 1, 0, 0, 1, 0. Okay. And now we have the process data set, right? So now what we do is like, we need to split the data set into training and testing. This also we have seen in the previous like model. So similarly, we are using the linear regression model over here, and we are trying to fit the X train and Y train. And here we are trying to predict. It's everything is similar. After this, only the difference is like the how you're working on the categorical features, and then how you're fitting it to the linear regression model. So here you calculate the R square and you calculate the intercept coefficient. Here you'll get coefficient for all the features, right? Because right now we have totally how many features? Normally we had 4, then we extended to 1 more, right? So then we have 5 features. 5 features, you understand, right? This one, 2 features, and from here it's 3 features. Okay, so this is how the model works. And similarly, there is some kind of like advanced linear regression models that you can use, some kind of stats model also. So basically, you know, the basic functionality is ordinary least square model, right? So in that stat model, what we can do is like, we can use, everything is a package over here. So you can just simply use the package, and you can train the model using the ordinary least square model, and you can fit and you can store the results. And here you'll get something called as like, if you want to know more about your regression results for the ordinary least square regression model, you'll have all these things. But this is not necessary for your assignment. This is just an additional information for you people to know about it. Okay. So this is the end of like multiple linear regression. So next we'll be moving on to the polynomial regression, which is also similar to whatever we have seen in multiple linear regression and simple linear regression. But before moving here, let's go on to the data set. So this data set is a bit different. Is a bit different. Okay. So here we are given the level, and which is okay, business analyst we are categorizing it as level 1, and the salary is 45K. So assume that I am a recruiter and I'm recruiting someone, and he says that I was a manager for this particular company, and he's telling that my salary is around like 1.5 lakhs or 2 lakhs. Then I can, based on this model that I'm going to build for using the polynomial regression, I can easily detect whether the salary that he's claiming is like is similar, or like it's like he's giving a over ramp up, okay, or like it's a kind of like bluff detection model, okay. So let's move on to the code. So as usual, we are importing the libraries, and then we are reading the data set, importing the data set. We are segregating the X and Y, and then we are fitting the linear regression model over here. And then here we don't need to do the testing and test split. I mean, we have only minimal data, right? So we don't need to do that. Then we are calculating the coefficient. We are calculating the regression, sorry, intercept. And then we are trying to use the polynomial features, and we are trying to increase the features into the power of the in the polynomial degree. So that is what we are doing it here. So for that, we have a package called as polynomial features in sklearn. So we are trying to fit the transformed features into the polynomial regression, and we are trying to use the linear regression model. One basic thing you can note from all these code is like you are basically using a linear regression model, but how you are fitting the linear regression model into your data is the main difference. Okay. So then we are printing the coefficient of this model, and then we are printing the intercept for this model, and then we are visualizing the results of the linear regression model. Here you can see that this is basically, if I'm using a simple linear regression model for this particular bluff detection, you can see how my regression line is usually straight, right? But it is not able to cover or like fit properly into the data. But when I use the similar linear regression model, but I'm trying to use it in a polynomial way. I'm going to do a polynomial regression using the linear regression. Then you can see that usually it can handle the non-linear relationship. So that is why it is fitting all the data points. So now you can clearly see from here, right? For a training data, or like for the data that we have used, the polynomial regression is actually overfitting, right? Because it is connecting each data point that we have. So it is too artificial. So for that, what we are trying to do is like we are trying to apply the regularization. Okay. So for regularization, we all know there is something called as lasso regression and ridge regression, right? So we are trying to apply the lasso regression, and we are trying to apply the ridge regression, and we are calculating what is the prediction after the application of the ridge regression, sorry, ridge regularization and lasso regularization. What is the prediction of ridge regression and lasso regression? So here you can see that it's a statement that here we have for a salary or for the position of 6.5, you can take the um, floor value, which is 6, for the level of 6. What is my salary? Okay. So here when we go to the position salary for 6, it should be 1 point, 15, 1.5 lakhs, right? So here you can see for the lasso regression is predicting approximately 1.3 lakhs, and ridge regression is predicting a closer value of like, sorry, 1.5, around like 1 point, nearly $1.5, $5 lakh. So this is why like ridge regression is better. We know why ridge regression is better, right? Because Lasso usually shrink the coefficient to 0, but Ridge tries to reduce the coefficient, but it will never go to 0. So this is the main difference. And I hope this is all about this session, webinar session. Now we can go to the Q&A session. Okay, so let me give you 5 minutes to post your queries. Yeah, you can use inbuilt sklearn methods also. Yes, we'll be sharing the notebooks in the webinar folder. Okay, so I mean, okay, so for the current assignment, right? You all will be submitting the current assignment through Taxila, but you'll be using virtual lab. Okay, but the final thing what you need to do is like along with the submission, you also need to show us the screenshot. With Professor Jayalakshmi ma'am has also informed you during the last webinar. So you need to share us the screenshot that you're executing the Python file or the the model file in the virtual lab. And right now for this assignment, you'll be submitting the assignments through Tax portal, and the submission instruction will be shared within today. So in that submission instruction, you'll have all these details, whether you can use an inbuilt function or not or whatever. But basically, you can use an inbuilt function like for NumPy or Pandas. For most basic complex operation, you can use a math like the packages. But usually for normal EDAs and all, you don't need to use a. It's not highly encouraged to use the inbuilt function. So anything that is regarding the ML assignment submission, right? You'll get the submission instruction within today, but post that you can always Teams myself or Professor Rajesh will be able to answer your queries regarding your submission of assignments. Actually, the IPYNB file and HTML file is fine, but the thing is like we want to make sure whether you people are using virtual lab, making use of the resources. So that is why we need screenshots, at least screenshots. And we completely understand you have only 22 hours of usage. But still we have already told you the way about like how to do it. You can do it locally and spark files to the virtual lab, and then you can execute it, have a screenshot, submit the screenshot along with the IPYNB file or HTML file. That's fine. Okay, stay like okay, all like whether whatever question you're posting, right? Why HTML file? Why what is a submission? All these things, everything will be shared in the submission instruction. After you have got the submission instruction, you can always ping us in your chat using your Teams chat. We'll respond to it. See, it's not screenshot of all outputs. Basically, like that you're executing in a virtual lab, we need that screenshot. Is all the pre-processing, right, scaling and everything you'll see in the next EDAs, next webinar. Here we are just restricting to the model building. Okay. Okay, multiple linear is something like you will have multiple features and there should be a linear relationship between the independent variable and the dependent variable. Polynomial is usually when there is non-linear. See, for example, in the data that we had, simply by giving 1 as an input feature, I cannot predict that 35K will be the salary, right? That is non-linear. So that is why we have used polynomial. So you don't need to attach screenshot in the IPYNB file. You just need to attach a screenshot separately or in the form of a PDF file. No, I'm not normalized the data. All these kind of data pre-processing, that's why I told you in this session, we are just focusing on the loading data and building the model. All the additional information on EDA, and we are ignoring it here. I have explained to you because you should know what is a pipeline, right? Yes, just one screenshot is enough. No, you don't need to have any handwritten thing on the PDF. Yes, it is mandatory to do it virtual lab because you have that resource and you should use it. You can do it in your laptop because I kind of very well understand that when you're executing in a virtual machine, you have some latency and delays, right? So it's okay to do that. But finally, you have to upload everything to the virtual lab and execute it, have a screenshot, and then submit your assignment. I think there should be also some marks assigned for you people who are like executing. Like if you're not submitting the screenshot of the virtual lab execution, then there'll be some mark detection also. I'm not sure. Let's have this discussion or like let's clarify this after the submission instruction is shared. Okay. Initially, 3 combinations are considered, and why later 2 is considered? Because you want to reduce there is something called as dimensionality reduction. So when you handle more features, right, your model will take longer time to process. So as of now, it's just 5 or 7 columns. That doesn't matter. When you take a intrusion detection data set, network intrusion detection data set, right, you'll have 50 features. So in that, mostly some features will be repetitive. So in that, usually in the EDA, you'll have something called as drop columns or like feature selection. So that's why we are converting 3 to 2 is basically we want to reduce the dimensionality. Yes, I understand virtual is very, very slow. That's why like you have the way, right? You can do it locally and you can upload to virtual lab. That one, I think last webinar, Professor Jayalakshmi ma'am has already explained. Which feature to consider, and I think it is based on some statistical measures, and also like what is a correlation. There's something called as correlation matrix or something. Okay, someone has already mentioned it's 0.5 marks for not executing in virtual lab. No, if you are not using virtual lab, you will be losing marks. I think it's 0.5. Someone has mentioned it. See, at least the final score, right? Uh, Assume that you're uploading your IPYNB file into the virtual lab in Jupyter Lab, you're displaying it. At least the final score RMSLE score or something like that, you'll have your final validation, right? For that, at least you run that cell to try to get a screenshot of it, the entire screenshot covering the virtual lab, okay, virtual lab environment. Yes, it should be posted as PDF. Thank you. Okay, that gradient step is basically for your understanding. So you have nothing to do with the, like, we know, right? Internally, even if I'm using a linear regression package, all these fine tuning is done based on the gradient descent. So this is just for your understanding. That's it. Why do we need XPredict? XPredict is something like for training how your model behaves. Okay. How on of VL on how to use cloud option. I think that's already there in the previous webinar, right? You need to log into your eLearn portal, then you'll have the connect to virtual lab, and then you'll get your remote virtual lab open, and then you can use your Jupyter lab. Okay, all this data pre-processing will be covered in the upcoming session because that's a part of EDA, right? Okay. I'll also, like, there is a folder called webinar. I'll post it in the channel where you can find the recording. See, it depends on the data set, what kind of linear regression that you want to apply. See, you can use any editor for your code, but the main thing is like you should use virtual lab for your execution, at least for demonstration of your execution. Can you explain epoch? You don't need to have very like clarification on the epoch because you'll not be using it here. So all these batch, everything will come in your DL sessions, right? So we are not covering anything else. We are just handling the queries. See, if you want to use the virtual lab for your practice, you can use. But the better way for you to, because you're all, you'll be doing your submission whenever you had time in the weekends or like after you post your work, right? So whichever is easy for you, you can do. The main thing is like, is not where you are doing, how you are doing your assignments and how you are executing it, how you are submitting it without any missing of files. That's it. Yeah. If you don't have any questions, if you are very clear, then you can drop. Thank you for your time in listening to the webinar. Thank you. Yeah, you're already a ML engineer, but still it's just 5% of what we are doing. But the most of the efforts is into the model building and deployment. That is where the real challenge comes. And still you'll feel more informative when you know about the EDA, expert data analysis and all. Right now it is looking very simple, right? Then you can successfully do your assignments. What do you mean by should we do a labware before attempting assignment? I don't understand this. Thank you, Harikiran. Thank you. Yeah, that's what, like, see, if you know how to access your virtual lab, right? Don't focus more on how I want to use virtual lab and everything. First, complete your assignments. That is a basic task. Even you know how to work on the virtual lab. If you don't complete your assignments, then it is of no use, right? So don't worry about it. First, complete your assignments. You have your IPYNB file, HTML file, and then you upload everything to your virtual lab. There, execute it, take a screenshot. Now you'll have 3 files, right? IPYNB, HTML, and the screenshot where you're executing your submission in the virtual lab. So upload everything to Taxila. That is the end of assignment. Okay. See, polynomial regression is very simple. So it's a same. Like you're trying to increase the feature into the degree, polynomial degree, so that you're making it very non-linear, helping the model to understand the non-linearity. Yeah, whatever you have some, I mean, doubts in the coding session, you can ask Divesh Kumar. Yeah, we'll go. The materials will be uploaded. I didn't say linear regression is defined in virtual lab. No, Vishwesh, I think you took a wrong understanding. I didn't mention linear regression is defined in virtual lab. Nothing is defined. Linear regression package. That one you can use it in your virtual lab, or see, virtual lab is an environment where you're using the Jupyter lab, or like, you know, it's a different environment. So out locally, you'll be running in your Windows system. Instead of that, you're using a virtual lab. That's it. HTML question, I think already Professor Rajesh has answered. So you just have to go to the file and do a save as. And don't worry about it. Even for like, even if you're unable to do it, you have a lot of other websites also who can do a conversion for you of your IPYNB file. First, focus on the IPYNB file and execute, code it, execute, get the results, and then worry about all the HTML and virtual lab submission. HTML file is simply like, see, usually when we are correcting, like evaluating, I just click the HTML file and it will open a HTML file so that we can easily go through the, instead of, downloading the IPYNB, uploading it in my Jupyter lab, then going, it reduces the steps. So that's why it's easy for us to evaluate. So that's why we need a HTML file for better evaluation. I mean, the HTML file will contain all your, each of the line IPYNB file line will be executed, right? All the results will be there at the end of each session. I mean, each cell. I think Surekar, I answered your question. How to generate HTML and how PNB file is there? Why we need HTML? You don't need HTML, but we need HTML. Okay. Yes, the file should be saved using your bits ID as file name. Correct. Thank you. See, polynomial regression, we already know the difference, right? See, linear regression, when you have one input and one output, you can use linear regression. When you have multiple input and one output, then you can use multiple regression. Then when you see that there is a nonlinear relationship between the input feature and the output feature, then you can use polynomial regression. We didn't skip any session. It's simply like I told you like that we have already covered in the linear regression code itself. Yes, it's again repeated question. You can use any environment, Colab, Jupyter Lab, or like VS Code, Anaconda, anything you can use. Why do you need to cover AND gate, OR gate, or XOR gate in ML? You'll not be doing that in ML. Okay, in deep neural networks, usually you'll have the LSTM networks, right? There you'll have the gating mechanism. So maybe in that, because in your theory classes, you'll be going into the mathematical foundation. Maybe in that you would have gone through this XOR gate and OR gate and all. So in ML, it is not there. Only where you use gating mechanism, LSTMs, RNNs, or not RNNs, GRUs, and maybe in LLMs. Demo video for what? I understand in 1 week you have to submit all 4 assignments, but still there's no other way. Oh, you cannot. Multiple files in the sense multiple submission is not allowed. Demo video of how to do the assignments, which means like, okay, whatever IPN PYNB file you know how to generate, right? This is how you do it locally. And the demo of like how to upload it in the virtual lab is already given in the previous webinar that happened on Tuesday. Professor Jayalakshmi ma'am has explained. You can refer to it. See, any submission details or queries, you can refer to the submission guidelines. Any other doubts? If the requested connection does not exist, please check the connection name and try again. Can you log out and log in again? Imani? Okay, others, if you don't have any question, you can drop. You Yeah, if it is inactive, it might get killed. So that's why I told you, right? Just for submission, you go to, I mean, taking the screenshot, you go to virtual lab. For all your coding and all, you can use your local machine. See, I hope the repeated question on virtual lab is coming from the students who haven't accessed virtual lab and worked on it. If you have accessed the virtual lab and worked on it, you will not have such questions because you know how complicated it is to work on virtual lab. I mean, whenever you code, right? There are so many people who are accessing the virtual lab because you just have only 1 week time. That one I don't know. This one I'm just Naveen. I'm just restricting only to ML because I don't have rights to say that. Can I? You can do it for everything. No, it's not. It doesn't work that way. It's only for AI ML you can do it. Again, a sincere request. Just focus on the assignment. Create your IPYNB file first. Then all your questions or like, problems related to conversion to HTML, how to access, how to take a screenshot, all these things are like very just 1 or 2 percentage. Okay. The main factor that is contributing to your assignment is the IPYNB file. So just worry about it. Leave out the other factors because you have lot of assignments to do. Okay. Any screenshot, see, basically, if I am referring to a screenshot, right, what I can do is like whenever I execute the error metric cell, I can take a screenshot of the entire window and submit, right? That's possibly a good way. Any more questions? Nilima, what question do you have? You have raised your hand. Students, you who don't have questions can leave the session. Mm. Okay, 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 fine, Nilima. Thank you, Bhavashu. Any questions? and